Hey guys, so in this video we're going to talk about the greatest common factor. So this is a type of factoring and it's usually the first type of factoring that you learn. So I'll just go straight to the definition. So the greatest common factor is the biggest common factor between a set of terms. So I think the easier way to explain this actually is with an example. So I've got 3x plus 3y. So what do you notice at these two terms? So the terms 3x and 3y, those are the terms. What do they have in common? It's the 3. And so that is the GCF, or the greatest common factor. So the greatest common factor is 3. So for me to factor that out, what I do is I write the greatest common factor down first, 3, and then I basically divide it out of these two terms. So if I divide the 3 out, then what am I left with? I'm just left with x plus y. And you know that you got this right because if you factor this back in like this, you get 3x plus 3y. So bada bing, bada boom, you're done. Okay, so let me just change it up slightly now and look at a different example. So the greatest common factor, it can be a number or it can be variables or a combination of the two. So it can be whatever, it just kind of depends on the problem. So for this problem, I have 3xy plus 6xy. So the largest number that would divide both of these terms is still 3, right? So 3 goes into both of these. But the other thing I want to point out here is that you have an x in each one of these terms as well. So because both terms have an x in common, that goes into the GCF. So it's like what are the terms, or what parts of this do they have in common? Do the terms have in common? So again, if I factor this out, I write the GCF down first. So if I divide 3x out of this term, I would just be left with the y. And then with this other term, if I divide the 3x out of here, I'm left with 2z. And again, if you were to distribute this back in, so we can just do that really quickly, this would give me 3xy and 6xz. So that's always the way that you can check this. Okay, so now what I want you to do is I want you to pause the video for a moment and just think about this one and come up with the GCF and factor it out. Hit play when you're ready. So in this case, so notice that everything is divisible by 5, and then all of these have an x in them. Now, this term has x squared, this has x, this has x. So what do you choose? So it's always going to be the lowest number of that variable. So in this case, this would just be 5x. That's what I'm going to factor out. If I tried to factor out, say like 5x squared, that would be difficult here because this only has one term of x. So you'd have like, you'd be dividing by this extra term of x, if that makes sense. So I'm going to write this out, 5x, and then I've got 2x minus 5y plus 3z. And so there is your factorization. Okay. So now for this last one. So I highly recommend that you pause the video and just think about this for a second and then hit play when you're ready. So I've got 3x to the 7th y plus 8x cubed z to the 5th minus 5y to the 4th z to the 3rd. So if you pause the video, you probably notice that no number actually divides all of these. And then also there's no like common variable or letter between all of these. So this one was actually a little bit of a trick question. The GCF, there is no GCF. So it's not like a guarantee that you're going to have one. So you just got to stay on your toes. So what do we say then when we can't factor it out? We say that the polynomial is prime. Okay, so now I think we've seen kind of the idea behind the GCF. So basically for the rest of this video now, I'm going to just give you a chance to practice this a little bit more. So I have these 4 examples. So if you want to try just a few more, you could pause the video here, give 1 or 2 or all 3 of, or all 4 of these a try, and then hit play when you're ready to see the solutions. So starting here with A, so notice that, so what we're going to do now in this case is we're not actually going to call out the GCF, we're just going to go ahead and factor out right away. So here, I see that 2 divides all of these terms, so I'll factor out the 2. And then notice, so I've got x, y in all of these terms. So since I have x and y in each term, I know that my GCF is going to include an x and a y, but what are the exponents on these? Well, it's always the lowest exponent that you see. So when I look at this, I've got x, x squared, and x. So what's the lowest amount of exponents for x that I see? It would just be x to the first. So I'm just going to leave this as plain old x. Now what about for the y's? It would be y squared, y to the fourth, and y to the fifth. So this y squared is the lowest exponent. So that's what I'm going to write here. So that's how you do this. And then if I factor that out, so let's see, this is going to leave me with just 6 plus 5x y squared minus 7y to the third. Now, what I did here, if you're not sure how I did this, I really was using the quotient rule. So if you think about it, if I'm trying to factor this out, so let's see, I'll just kind of blow out the detail here. So let's say I've got 12x squared divided by 2xy squared. Well, what you're really using here is the quotient rule. So like here, these x's and these y's drop out. So I'm really just left with 12 divided by 2. And so that's why for this first one, I just got 6. And then when I divided 2xy squared out of this term, so out of 10x squared y to the fourth, and then I'm dividing out 2xy squared. Okay, now in this case, so 10 divided by 2 is 5. But for these exponents here, I'm going to use the quotient rule, so I'm going to subtract them. So 2 minus 1 is just going to give me 5x. And then this y to the fourth, and then y squared, I'm going to take 4 minus 2, and so that's going to leave me with y squared. So that's kind of the way that you'll work with that. And then that's what I also did for this last term here. Okay, so moving on. Okay, so now I've got b here, and I've got 5xy minus 10yz plus 12xz. So once again, we do not have the case where all three variables, like that you don't see a common variable in all three terms. And then these are not divisible by the same number. So this one is once again just prime. Okay, so now moving on for C here. So notice that they all have an x in each term, so x squared and x cubed, and they're all divisible by 3. So actually what you're going to factor out in this case is going to be 3x. Now, keep in mind, how do you factor out 3x from this? What are you left with? Is it 1 or 0? It would be 1. 3x divided by 3x equals 1. It doesn't equal 0. Now as I continue on, this is going to give me 1 plus 2x minus 4x squared. Now here is a quick check you can do for yourself if you're not sure if you actually factor this out properly. So notice that I have 1, 2, 3 terms. So when I factor out the GCF, I should still have 3 terms in my parentheses. So that's a quick check. Every once in a while, I'll see just people who are prone to they'll try to do this, but they'll end up writing 0. So if you are prone to that, you know, it happens. So just use this as a quick check for yourself. I had 3 terms here, so I need 3 terms in here. Okay, so now for this last one. So I've got 5x to the fourth, y squared, z to the fifth, plus 10x squared, y to the fourth, z to the sixth, minus 25x to the fifth, yz to the third. Okay, so first of all of these terms are divisible by 5, so I'll factor out the 5. Now notice, all of these terms have an x, y, and a z. So x, y, and z will be a part of my GCF, and now I just have to figure out what exponent goes here. And so all you have to do is look for the lowest number exponent among your terms. So here I've got x to the fourth, x squared, and x to the fifth. So x squared is that lowest exponent. And then for the y's, so I've got y squared, y to the fourth, and y. So I just leave y here. And then finally, z to the fifth, z to the sixth, and z to the third. So the third will be the lowest power. And so now there's my GCF. So now I can factor it out. So when I do that, I'm left with x squared, let's see, x squared, y, z squared, plus 2 y to the third, z to the third, minus 5 x to the third, and that would be it for that one. Okay, so you always want to look for the GCF whenever you are trying to factor something out. GCF is always fair game with all factoring, and you've now got a pretty good idea of how to do it. So that concludes this particular video. You got any questions, you can always leave me a comment. Thanks for watching, guys. I'll catch you next time.